All right, in today's lesson, we're finishing up Unit 6 with notes 6.5 on inverse functions. If you're watching this for the first time, you will need to copy down several of these things. If you're watching this after you've already seen it in class, you will notice that in class I wrote everything down, and in the video I'm just trying to speed it up by having this this template for us to fill in together. Okay, so we're looking at inverse functions, and we're going to look at notation. We're going to talk about what it is, how to find it, how you have seen it in the past, and then how you're going to see it in this class, and then what does that have to do with what we've been doing recently. Okay, so for notation, all right, let's just say that we have some relation R, and I want the inverse of it. All right, well, the inverse is written like this. It's R, and it looks like it's raised to the -1. Okay, so -1 is kind of like the exponent, but that means it's the inverse of R. And to find the inverse of a relation, all you have to do is switch, oh, can't spell, sorry, switch the x's and y's. Okay, so you did a little bit with inverses in Algebra 1, and this is what it looked like. Let's say you were given some set of ordered pairs, and you were asked to find the inverse of it. Okay, well, you may not have used this notation. You may have just said, the question may have just said, find the inverse. And the inverse literally takes every ordered pair, which is an x and a y, and it switches them. Okay, so instead of the ordered pair 1, -2, the inverse is -2, 1. Instead of 2, 4, the inverse is 4, 2. Instead of 3, -1, the inverse is -1, 3. And last but not least, instead of 4, -2, the inverse is -2, 4. Okay, and that's all you did with inverses in Algebra 1. Okay, if you even remember that. All right, so number 2 should be super simple. Maybe consider pausing it and trying this one on your own real quick. When you learned this in Algebra 1, you were also asked other questions like, is it a function? Is the inverse a function? We're not going to get into all of that in this class, although a function just means none of the x's repeat. Okay? All right, so let's take it a step further. Let's take the equation of a line, or let's take the graph of a line, and let's come up with the inverse of that graph. Okay? Well, notice that I have marked some points on this graph. So if I can label those points, okay, if I can label those, oh, that's not -2, sorry. That's -1. All right. Again, if I can label those points, then I should be able to just switch the x's and y's to get 4 new points on my inverse. Sorry. Okay, and so I'm just going to plot those 4 new points. One of them happens to be the same. Okay, and then I would connect them with what I hope is a straight line. Okay, and yes, technically it should have an arrow on both ends. Okay, and so again, all I've done is I have found 4 points that I can actually see, and I have switched their x's and y's. Okay, now how do you find the inverse from a equation or function? Okay, so since we're talking about function notation, we're going to be talking about f of x. And so when we talk about the inverse of f of x, here is the notation. It's f with a little, like a -1 exponent of x. And you read it f inverse of x. That's how you read it, f inverse of x. And so if I want to find that inverse, okay, here's what you do. Here are your steps. So you want to pause it and write these down. You have to first replace f of x with y. So instead of f of x equals whatever you've got there, you want it to read y equals 2x minus 4, okay? Because you can't switch the x's and the y's if there is no y. So f of x is the same thing as y. So replace that. Then the second step is to literally interchange x and y, switch them. So wherever you see a y, put an x. Wherever you see an x, put a y. That's step 2. Then step 3 is to do whatever algebra it takes to solve for y again. Get y by itself, okay? Get the new y wherever it is, get it by itself. All right, so let's see, I'm gonna have to add 4. Then it looks like I'm gonna have to divide by 2. And since we are gonna be simplifying, please keep in mind that you're gonna need to divide each piece by 2. And keep in mind that there's technically a 1 in front of that x. So when I divide by 2, I get a 1/2 in front of my x, and 4 divided by 2 is 2. That is a simplification you're going to need to be able to do. All right, and then last but not least, step 4 is to change the y back to proper function notation. But you have to remember that you've just created the inverse. So you're going to change your y to f inverse of x. And then if you want to put what it's equal to after that, it's probably a good idea. Okay, so it sounds like a lot of steps, but it's not a super large amount of work or math. It's just remembering when to change things and when to change them back. Okay, so I'm going to show you the next one with a little bit of a shortcut. So I'm going to be lazy and I'm going to say, okay, well, f of x is my y. I'm not going to rewrite the whole thing. I'm just going to stick the y right there. And so then the first thing I actually write down in a new step is I'm going to switch my x and my y. Okay? And now I'm ready to do whatever math it takes to get y by itself. Okay? So I'm going to -1. All right, make sure you remember that you're minusing 1, not multiplying by -1. Okay? And then you have to remember, how do you get rid of a fraction that's connected by multiplication? Because it's not really pretty to divide by a fraction. So it's going to be better if we multiply by the reciprocal on both sides. And you absolutely need parentheses so that you remember, you don't forget that you're going to need to distribute that -5/2. Right, so we get -5/2 x plus 5/2. And the reason we did reciprocals is so that they cancel on this side. And now our y is by itself. And last but not least, you need to rewrite your y as f inverse of x, and then put your equal stuff on the other side. Okay, because it just looks better when f inverse of x comes first. Okay. All right, and that's pretty much it. But our problems are just going to get a little bit more. There's just going to be more algebra to do. Okay, so let's keep practicing. All right, so same directions. Find the inverse. So we change f of x to y equals, and literally switch the x and the y. And now we have to figure out what math is going to be required to get y by itself. All right, pause it and think about it. Come back to me. All right, hopefully you got rid of the bottom first, because you can't move anything off of the top if there's still a bottom sitting there. So that gave you 2x equals 7y plus 18. All right, so now we have to subtract 18 from the right over to the left, and then we're going to divide everything by 7. Okay, now as I divide each piece by 7, I need to think about, am I going to be able to reduce it? And I am not. And then last but not least, don't forget to rewrite it with proper notation. You're telling me that you have now created the inverse function. Okay. If this test ends up being handwritten and you forget to rewrite it with function notation, with the F inverse as your final answer, then you will lose a point. Okay. All right, number 7, make that a Y. Switch the X and the Y. Oh, okay. So now I have a square and I have a parenthesis squared. Well, remember, we're trying to get Y by itself, so we don't really want to FOIL this out. We just want to start trying to get everything away from the Y. And so the process there is going to be to subtract the 2 first. Okay, and then you have to remember how to get rid of a square. You're going to have to take a square root. All right, and so that gets rid of the square on the Y minus 5. But there is no square on the x minus 2, so the square root's going to have to stay on it. And because you took a square root, you need a plus and a minus. And then the last step is going to be to add that 5 over. All right, and remember, when you add something and there's a plus and a minus, you want to put that new number in front of the plus and the minus. Okay, so that kind of brings in a skill that we've looked at before. And of course, last but not least, you want to change your notation to the inverse. And so here, the inverse is actually equal to 2 different functions, 5 plus the square root of x minus 2 and 5 minus the square root of x minus 2. And if we were spending more time talking about the domain, then we could actually, we could tell when to, we would talk more about when to use the plus and when to use the minus. But that's not something we get into real deep in this class. Okay. All right, I've got 2 more for us to practice. So again, I strongly encourage you to pause the video and try them on your own. All right, and then come back and check. So I made my f of x my y, then I switched my x and my y, and I have to figure out how to get y by itself. So it looks like I'm going to have to add 1 from the right to the left. It also looks like I'm going to need to divide by 6. Let's see, I'm going to have to divide that by 6. So I get 1/6 x plus 1/6. And then I have to remember how to get rid of a cube. And we do that by taking the cube root. Okay. So we get the cube root of 1/6 x plus 1/6 equals y. And then we need to just change up our notation. All right. And last but not least, all right, let's get everything switched. All right. Now, for this one, you have to be careful because you cannot get rid of the 6 on the bottom when that whole thing is under a radical. So you actually need to get rid of the radical. And since it's a cube root, we're going to get rid of it by cubing both sides. All right, so again, that's a skill that we learned in a previous unit. You get rid of a cube root with a cube. All right, and so that just leaves me with y divided by 6. Now I can get rid of the 6. And I have 6x equals y. And so last but not least, I can do my proper notation. Whoops, forgot, hold on. That is x cubed. So that is still x cubed, and that is x cubed. All right, there we go. Okay, now what else are we going to do with inverses? And what does that have to do with other things that we've done in this chapter? Well, sometimes you're going to be asked to decide, you're going to be given two functions, and you're going to be asked if the two functions are inverses of each other. Okay, now that doesn't mean sit there and like figure out the inverse for the first one, figure out the inverse for the second one, and see if they match. Okay, it doesn't work like that. To determine if two functions are inverses of each other, so let's call them f of x and g of x, we know they will be inverses of each other if f of g of x equals x and g of f of x equals x. So that means we have to compose our two functions. That's what we learned in our last section, 6.4. You have to compose the two functions together, and you have to get x both times to prove that these things are inverses of each other. Okay? Now, when you do these, you have to label which one you are doing. Okay? Because I have to know that you understand composition. So you have to label which one you are doing. So like, set each one up, f of g of x and g of f of x. And then you have to show every single step of plugging it in and simplifying it, because you have to prove to me that you get x. Okay? All right, so here's my work. For the first one here, I need to put g of x into f, right? In place of x. So I'm going to take all of this, I'll bring it over here, and put it in place of x. So I'm going to have 2 times, but instead of x, I'm going to have 1/2 x plus 2. Then I still have this minus 4 that I have to bring down. And now I have to show all the math and simplify. So I need to distribute my 2, and I get 1x plus 4. Then I have a minus 4. And look at that, 4 minus 4 cancels, and 1x is the same thing as x. So that one works, but that's not enough. You have to do it, you have to compose both ways. So now we're going to take f of x, and we're going to put it into g. So we're going to take f of x, to put it over here, beside the 1/2 in front of the plus 2. And then you have to show all the math, and hopefully you'll get an x. So we're going to distribute the 1/2, and we get 1x minus 2. Bring down the plus 2, and look at that. Minus 2 plus 2 cancels. 1x is the same thing as x. And so the question was, are they inverses of each other? That's actually the question. And since we got an x for both, the answer is yes. If you get anything other than x, the answer is no. Okay? All right, so let's try another one. All right, again, you need to make sure that you write down your two compositions, because I have to make sure that you understand which one is which and how to do each one. All right, and then you need to show the work. All right, so G is going to go into F in place of X. So -4 times, we're going to put all this stuff in, and then we're going to add 5. Okay? Now, when you distribute -4 times x divided by 4, the 4's can cancel, but I still have to do the negative times the x. And then -4 times -5. All right, and hopefully you can see right away that you definitely do not get positive x. And so if one of them doesn't work, you can automatically say no and be done. You do not have to try to work the other one if the first one does not work. Now, keep in mind, you may have made a mistake, so it is helpful to work out the other one. Because if they both don't work, then you're more likely to be correct if neither one of them work. Okay, couple more. Whoops. Couple more. I want to just keep showing you some, they could get a little more complicated here. So Same thing though, we're trying to prove or show that these are inverses of each other. All right, so I'm going to start by taking G and bringing it over here and putting it in place of X. So here's my G. When I replace the X, I have to square it and add 8. All right, well, remember what happens to a square root and a square? They cancel each other out. Oh, so that one's going to work out nice. All right, but that is not enough. It is not enough. You have to compose both ways. So now I'm going to take the x squared plus 8, and I'm going to bring it over here, and I'm going to put it under the square root in place of x in front of the minus 8. Now notice that's all under the square root. So because of this addition and subtraction, you cannot square root just the x squared. But the plus 8 and minus 8 cancel each other out. So then you can square root the x squared. Okay? And that does give you x. And since we got positive x for both, the answer is yes, and we are done. All right, and then I threw a tricky one in here, one that you got to have some patience for as you work through it. But I wanted to make sure that you saw anything as anything complicated that you might see in your homework. I want to make sure you had an example of it in your notes. All right, so we're taking this whole cube thing, and maybe you need to draw circles too. All right, and you're putting it under this cube root. So this whole thing is going under that cube root. But then don't forget you still have a minus 2, and it's all divided by 3. And you have to make sure, this is why it's important that you show every step, you have to make sure that you show me what disappears first, second, third, and so on. All right, so this subtraction is not under the root, under the radical, so we can get rid of the cube root with the cube. And that means we can drop the parentheses. Okay, then, all right, again, you have to show me what disappears first, and you cannot divide this by 3 unless you're going to divide everything by 3. So let's get rid of the 2's first. Positive 2 and negative 2 cancel. Then the 3's can reduce. Okay, and you actually get x. Wonderful. So that means we definitely need to move on and try the other one. All right, so this time, and this is where I might pull out my handy dandy eraser. Okay, this time I'm going to take this whole fraction, ooh, this one's going to be crazy looking, and put it here next to the 3. So it's going to be, so parenthesis 3, then times that whole fraction. Then we have a plus 2, and then we have a cube. Okay, and we have to simplify in the proper order. Okay, so we start inside the parentheses, but inside the parentheses, we have a multiplication problem. Luckily, 3 times something divided by 3, the 3's cancel. Okay? And this is what we're left with. But then we still need to simplify inside the parentheses to see if anything else goes together before we take care of the exponent on the outside. And now the cube root and the cube cancel, and I get x. And since they both equal x, they are inverses of each other. Okay? I know some of those take a little bit longer, but it's really good practice for composition. And so you should be experts at composing 2 functions together when you're finished with this. Okay, and that concludes our Unit 6, and we will be preparing for a test soon.